All right, so we can use, after we've divided our curve, or divided the region into subdivisions here. We could use the left endpoint, we could use the right endpoint, and that's going to be the right endpoint of the subdivision. Or we can use the midpoint. And that would be the midpoint of the subdivision itself. I'm going to start off with, and the first one that we're going to use is, we're going to figure out the left endpoint. So this is the first one we're going to use. Now, when we are looking at a graph, and what we'll do is, once I know that the width is 1, you can almost break it up. This is your first interval. Now, this would be left endpoint. That would be the left endpoint of this first interval, that first subdivision. And what you're going to do is, we're going to create a rectangle, because rectangles are easy to deal with. And since we're figuring out areas, if we use rectangles as areas, then it's going to be the easiest shape that we can use to actually, I don't know, it's all messed up today. Today's just a bad day. Today's one of those days where you didn't want to get out of bed. Alright, so this rectangle, the width, is going to be equal to the width of the subdivision the length, which you can think of the height, is f of x at the left endpoint, which would be, what's my value of the function at the left endpoint? 0. So this one actually, there's my rectangle. It's not a very good rectangle, but it's a rectangle nonetheless. So now we go to our second interval, which is from 1 to 2. What's the left endpoint of 1 and 2? 1. So I'm going to draw my rectangle that went up to f of 1, which was equal to 1, and then I go to 2 like this. Now, if I'm going from 2 to 3, what's the left endpoint? 2. So I'm going to follow 2 up to f of 2, which is equal to what? That's equal to 4. And my last interval is from 3 to 4. What's the left endpoint? 3. So I'm going to create my rectangle here. F of 3 is equal to 9. Now what we do is, let's figure out the areas of the rectangle. We'll start like with rectangle 1, rectangle 2, rectangle 3, and rectangle 4. Rectangle 1, what's the width? The width is 1, so it's 1 times what's the height? 0. So we get 0. How about the second rectangle? The width is 1. What's the height? 1. So it's 1 times 1, which is 1. Rectangle 3, what's the width? 1. What's the height? 4. So I get a 4 out of this. And rectangle 4, the width is 1. What's the height? 9. So that's a 9. And if I add these up, and this is why we did the summation, and we'll go over the summation probably tomorrow, because it wasn't that big of a deal. It's nice that you did it, but this is basically, we're thinking of this. The summation, I equals 1 to 4 of the areas of the rectangles. So if I add these up, 0 plus 1 plus 4 plus 9, what am I going to get? 14. So this is the left. Oops. That's your left endpoint approximation. Kinda. Now, is this the actual area? Why do you say no? Yeah, all these little areas here, these aren't rectangles because that's a curve. Those that I just highlighted? No, those, we already did those. Yeah, that's what you do. You take the areas of those. Now, is this 14? Well, that didn't help any. But that 14, is that bigger or smaller than what the area should be? All right, that's smaller than the area. That's not good. All right, now let's look at the right endpoint approximation. So we're going to do the same thing. We know this is f of x is equal to x squared. Now for the right endpoint, I'll use blue this time. From 0 to 1, what is the right endpoint? 1. So I'm going to take that up, and I'm going to make this rectangle. That's R1. Now for R2, am I going to use 1 or 2? Now between 2 and 3 for rectangle 3, I'll use 3. So I'll go up to where the graph is at 3, and that will be the construction of my new rectangle. And for 4, am I going to use 3 or 4? Is that a question? I use that. Now, for R1, what's the width? 1. What's the height? What's this height right here? Well, it's 1 squared, isn't it? Which is 1 times 1, which is 1. So R sub 2, so the second rectangle, the width is 1. That's going to be 2 squared. So we get a 4. Now R3, the width is 1. So we get 9. And R sub 4, what's the width? and that'll be times 4 squared, which is 16. So that's 1 plus 9 is 10, that's 26, that's 30. Is this bigger or smaller than the actual area? So now the area is somewhere between 14 and 30. There's another way that you can do this. So if we do a midpoint, we're going to use, in every single case, I want to use the midpoint of the interval. If I'm going from 0 to 1, what's the midpoint? Half, or 0.5. So this rectangle would be right here. And for rectangle 1, width is 1 times 0.5 squared, which is 0.25. Now, what is the midpoint between 1 and 2? 1.5. So I'm going to take that to the graph, and I'm going to create the rectangle. Now, what's 1.5 squared? That's 2.25. Now, what's the midpoint here? Yeah, 2.5. So this would be 1 times 2.5 squared, which is 6.25. Then what's the midpoint here? And so our 4 is 1 times 3.5 squared. Well, what's 3.5 squared? $12.25. Close enough. Close enough for government work. Now, if I add up all of these, I get the area to be 21. Which one of the three do you think is the closest one? 21. Sometimes in this case, the midpoint was looks like it's the better one. Sometimes the right end point is a better approximation. Sometimes the left one is. Sometimes the midpoint one is. You have to get used to using all three of those. And there's another one that we'll learn in a couple days called the trapezoid rule. But this is how we would do this in a graph. And so we get kind of an area underneath that curve.